Okay, this is section 6.3, part 2, or day 2, where we're talking about vectors on a plane, so we're looking at air bearing this time. We've done sea bearing, but now we're going to do air. So, our first example is an airplane is traveling at a bearing of 295 degrees with a speed of 437 miles per hour. And there is a 44-mile-an-hour wind that is blowing in the direction of north 38 degrees east. Find the resultant speed and bearing. Now if we look at this, some key pieces of information is we have our bearing for our airplane of 295 degrees. And the speed of the airplane is 437 degrees. The wind is 44 degrees, or 44 miles per hour, and it's going in the direction of north 38 degrees east. Just like with our sea bearing, we're going to draw a picture. Now, there's a couple ways to do this. One, we could draw one big picture of both the wind and the plane together, or we can do them separately. I prefer doing them separately. It's up to you. Mrs. Armstrong might be a little bit different. For me, I think it's easier to see when they're separate. So if I draw the picture here, I'm going to just do the plane over on this side. And then we're going to talk about how to solve this problem. So let's draw our picture first. Now, air bearing works differently than sea bearing. Air bearing is always off of due north, so our north is right here. So we're going to go 295 degrees off due north, which means we're going to go all the way around till we get to here. Okay? And that last line just kind of not right out the center. There we go. Okay? So that's our 295 degrees. The speed of the plane, the 437, is actually the magnitude of this vector. Okay, so this was 295. And then we have our magnitude. So there's our plane. Let's do our wind. Okay, so the wind is north 38 degrees east, and we're going to do it exactly the same way as we did our sea bearing. So northeast goes this direction. So that 38 is right here in this little nook. Okay, and again, the magnitude of this vector is its speed, so this is going to be 44 miles per hour. Okay. Now the way we're going to solve this is we're going to basically take the plane vector plus the wind's vector, and that's going to give us our resultant. Which is our resulting vector for the two of them. And this is the important thing, because that resultant's going to help us find the new magnitude of the vector, which is our speed. Notice the magnitudes of both of the previous ones was the speed, and it's going to tell us the direction. So it's going to tell us our new bearing. Alright, so the first thing we have to do is find that resultant. So let's set up our plane vector. Okay, using our component form for a direction vector. Now our magnitude's bigger than 1, so our plane is going to equal, I'm going to make this a little smaller, hold on, so I have some room here. So the vector for the plane equals our speed, which is 437, and we have our cosine and our sine. Now the thing we need to be paying attention for is we're not going to use the 295, because when we do our cosine and our sine, it's always off the x-axis, and this one's off the y-axis. So what we have to do is we actually have to find our reference angle. We have to find this angle right here. This is our reference angle, and that's our theta that we're going to use. So this, our bigger angle is 295. If we go, I'm going to pick a different color here. From here to here, that's not, you can't really see that. Hold on, let me get a different color that you can see. Let's do yellow. Here to here is 270. So if I want to find theta, I'm going to take 295 minus 270, and that gives me 25 degrees. So we want to use the reference angle. We don't want to use the bearing. We need to find our reference angle, and the reference angle is always off of the x-axis, because it has to be where the initial ray is on the x-axis and the terminal ray can be somewhere else. All right. So this is going to be the cosine of 25, comma, sine of 25. Now the other thing we have to look at is our reference angle doesn't take into account our positive and negative values. So we have to do that. And if we're in the second quadrant up here, I know that cosine is negative, so I'm going to put a little negative sign in front of the cosine. If sine had been negative, I'd put a negative in front of sine. So we have to pay attention to that. Now let's do the vector for our wind. Again, it's going to be 44, the speed, times, we need to find our theta here as well. We need to find that reference angle. And again, that reference angle is right here. This is our theta, and it's going to be 90 minus 38, which is 52 degrees. So again, we do the cosine of 52, comma, sine of 52. I'm going really slow on these first two because I want to make sure, or this first example, and then we can speed it up. So now remember, to find our resultant, we're going to add these together. So I'm going to write an equation adding them together. So 437, hold on here, let me rewrite it. And remember, we also have our scalar multiplication where we can take that magnitude and multiply it on the inside. So I have the negative 437 cosine of 25, comma, 437 sine of 25, plus 44 cosine of 52, 44 sine of 52. And our resultant is just adding these two together. And so that would be the negative 437 cosine of 25 plus 44 cosine of 52, comma, 437 sine of 25 plus the 44 sine of 52. Okay. And we did this last class where we could take two vectors and add them together by adding their components. Now we're going to use our calculator and we're going to find our resultant vector. So our R, I'm going to use R to represent resultant, is going to equal, so type the first thing into our calculator, and we do need to store both of these values because we're going to be using them a couple of times, so you want to store both of them. So negative 437 cosine of 25 plus 44 cosine of 52 gives me negative 368.9674. And again, you want to store that. And because this is like the x value, I'm going to store it actually as x. Alright. So I'm going to store that in my x. Now do the same thing for y. Go 437 sine of 25 plus 44 sine of 52. And I get 219.3567. Same thing. This is kind of like a y, so I'm going to store it under y. Store in y. Alright, so this is our resultant. And you're probably like, okay, so what does that tell me? Well, one, it kind of tells me what quadrant I'm in. My x is negative, my y is positive. I'm still in quadrant 2. Okay? So when I'm going to find my new bearing and everything, I need to remember that. So now let's find our speed. So the speed is going to be the magnitude of that resultant vector. So to find the magnitude, remember we just square the first value of our vector. So this is going to be the square root of the negative 368.9674. So I'm going to just use, because I stored it in x, I'm going to use x. So it's x squared plus the 219.3567, that value squared. And that's going to give me my resultant speed. Which is 429.2485 miles per hour. And so does that make so let's look at it. Our plane is supposed to be flying at 437. The wind, it's kind of hitting it towards it's pushing the plane. It's kind of pushing the plane that way. So it's probably going to slow it down a little bit. Not too much, but just a little bit. And so that seems about right. Now let's find our bearing. To find our bearing, it's going to be is the new theta, or we can use whatever we want. If you want to use alpha, beta, it doesn't matter. You can. So I'm just going to use theta again. And that's going to be found by taking the tangent of theta is equal to the absolute value. And you're probably saying, well, why are we using absolute value? Well, because we're using reference angles, our calculator won't recognize some things. So we're always using reference angles, which the calculator knows them to all to be used positive. So we need to tell it it's positive. And that's going to be the y over the x. So absolute value of the y divided by the x and tangent of that. And I get that theta is about 30.7321 degrees. Now, here's where it gets a little complicated. That's the reference angle. That's not our official bearing. Because our bearing is in the second quadrant, we have to go all the way from the top. So I'm going to So our bearing says we're over here. This is our theta. So we have to go all the way around. So we're going to add 270 to our theta. And that's going to give us our final bearing. So the plane has a bearing of 300.7321 degrees. Okay, so that's the first example. Let's go on to the second. Okay, so let's look at the second example. An airplane is traveling at a bearing of 214 degrees with speed of 507 miles per hour at a fixed altitude. A 36-mile-an-hour wind is blowing from the direction of south 72 degrees east. Find the resultant speed and bearing. Alright, so let's start with our plane. We're going to draw our picture. And the plane is going at 214 degrees. So starting at due north, here's 180. 214 is not quite all the way to the next so it's about right there. So that's 214 degrees. And our speed is 507. So I'm going to put 507 here. So let's write our vector for this one. So I need this angle in here. This is the angle I need. So I'm going to find that by taking the 270 minus the 214. And that's going to give me 56 degrees. Okay? So here's my vector for my plane. 507 cosine of 56 sine of 56. Now pay attention what quadrant we're in. We're in the third quadrant. Sine and cosine are both negative, so I'm going to make these both negative. Now let's do our wind. Okay, so the wind is going southeast. So this is this direction at 72 degrees. So actually I'm going to move that so it looks a little closer. So it's more like this. This is 72 degrees. At a speed of 36 miles an hour. So for this one, I want this angle in here. This is the angle I need. And that's going to be 90 minus 72, which is 18. So let's write the vector for our wind. Our wind is going to be 36 cosine of 18 sine of 18. Again, paying attention to what quadrant we're in. We're in the fourth quadrant. Cosine is positive, but sine is negative. So now we're going to add the two things together. And I'm going to actually kind of not do what I did last time where we wrote out each part. We can put it all together. We know we're adding it together. So 507 times negative cosine 56. It's just going to be negative 507 cosine of 56. Adding it over on the other side, is 36 cosine of 18, comma, now let's do our sine. Negative 507 sine of 56. 36 times negative is going to be negative 36 sine of 18. Use our calculator to find our resultant. Negative 507 cosine of 56 plus 36 cosine of 18 is negative 249.2728. Again, I'm going to store that in x. Okay. Now let's do our y. Negative 507 cosine of 56 minus 36 sine of 18 this time. And I get negative 294.6354. Okay, so our resultant vector is still in the third quadrant, which makes sense. So the wind isn't that strong. It's still pushing it, but it's not pushing it into another quadrant, which is okay. So we know where we're at. Sometimes they will push them into other quadrants, so you have to pay attention to what your resultant vector, where it shows up, which things are negative, which things are positive. So let's find our speed. So the speed is going to be the resultant of r, and that's going to be the x value squared plus the y value squared. Hold on. I just caught a mistake. I typed in cosine instead of sine here, so I need to erase this. I am sorry. Glad I caught it now and instead of later. So negative 506, or 507 sine of 56, not cosine this time, minus 36 sine of 18. That's a little different. Negative 431.4467, about, don't need that all the way over there. I'm going to store that in alpha y. Alright, so now let's find that resultant. So the square root of x squared plus y squared gives me 498.2802 miles per hour. Okay, so the speed is a little slower. The wind is hitting that nose, so it's kind of slowing that plane down just a little bit. Now let's find our bearing. So the first thing I need to do is I need to find tangent of alpha. And that's going to be absolute value of y over x. And we already have these two values. We already have them stored, so we can say absolute value of y divided by x, and then inverse tangent of that. And I get theta is about 59.9823, or 24 actually, degrees. Okay, so if you remember where we're at for our bearing, we are in the third quadrant, so we are down here. This right here is our theta. But I don't want that. I want, let me find the bright red. This is my bearing. So to find that, I'm going to take the 270 minus my theta to get my bearing. Because basically I need to go all the way up and then back it down. So I'm going to go for my bearing. This is 270 minus theta. And that's going to be 210.0176 degrees. Okay, so there's your two air bearing examples. You notice the second one was a lot faster. It gets faster as you go going. Alright, if you have any questions, make sure you bring them to class with you.